G'day. Here's a question. Why do you flip the inequality sign when multiplying or dividing by negative numbers? A lot of people have been asking me that. All right, so where does my brain go in response to that question? Well, yes, I definitely remember being trained as a child. If I got an inequality like this, that negative 2x is negative 2y, obviously I want to divide both sides by negative 2. I was told, go ahead and do that, but flip that inequality sign as you do it. So it's just a law, do it because you just do it. There's got to be a reason for it. What's really going on? How do I help my thinking brain with this particular process? Well, to answer that, let's be really clear about what inequality is and what we believe is true about inequality. So inequalities are motivated by balances, keeping things in balance or out of balance, actually keeping things out of balance. For example, when I say 5 is bigger than 3, I really mean in a sort of a physical sense, or one my physical model that motivated this idea, I got some sort of balance pans, some sort of scale between two balance pans that has 5 apples in one pan, 2, 3, 4, 5, and 3 apples in another pan. 5 apples weighs more than 3 apples. The balance is tilted this way. We've got an imbalance. 5 is bigger than 3. Though I think textbooks don't use balance pans anymore because most students have no idea what a balance pan is. I think they use mobiles or little hanging chart things. Okay, but nonetheless, it really comes from the idea of inequality comes from the notion of balance and being out of balance. But let's see what I believe. What do I believe about this scenario right now? Well, I certainly believe that I add one apple to the left and add one apple to the right, if I add one and add one, things will still be imbalanced in exactly the same way. It won't change the nature of this imbalance. Okay. In fact, instead of adding one apple to each side, what if I added 3 apples to each side? So I did 1, 2, 3, 1, 2, 3. I still believe this imbalance is going to happen. In fact, I could add any number I like to each side. I'm going to add k apples to the left and k apples to the right. I'm going to maintain that same status imbalance. Okay, that's not going to affect my imbalance. This will still be heavier than that. So there's a fundamental belief of inequalities, that if I have A is bigger than B, then I can actually add anything I like to the left and the same thing to the right. Well, it's B plus K, make it a little bit neater, B plus K, and I will maintain the imbalance. So this implies that. And I could be sneaky. I could actually, in some sense, add negative 2 apples to both sides, but adding negative 2 means subtraction. I could subtract equal amounts of apples from both sides, and my intuition tells me in this model, I will still have the same imbalance. So this number k could be positive, add apples to each side, or it could be negative, subtract apples from each side. Either way, truth is maintained. All right, so this physical model that motivates inequalities suggests we should believe this statement of inequalities. All right, there's a second statement of inequalities that this model motivates and suggests that should be happening mathematically. For example, right now I've got 5 apples being heavier than 3 apples. Let me double the number of apples and double the number of apples on the left and double the number of apples on the right. So now I'm going to say 5 is going to be an extra 5 makes 10 apples on the left and 3 apples on the right, another 3 apples on the right, making 6 apples on the right in total. Sorry. But my intuition tells me this is still imbalanced in exactly the same way. This is still heavier than that. Or if I triple the number of apples on the left and triple the number of apples on the right, or tenfold the number of apples on the left and tenfold the number of apples on the right, I'll still maintain that imbalance. Okay, I did go to negative numbers here, but I'm worried about multiplying by negative numbers because I have no idea what this means in my physical motivation. I have no idea what it means to multiply 5 apples by negative 2 and 3 apples by negative 2. That seems scary to me. So what do you want to say? Don't do it. Don't do it. But I can at least say, if I stay with positive numbers, that k times a and k times b would actually be the same imbalance as long as k is positive. So if I got this imbalance to begin with, feel free to add and subtract apples from each side. I still believe they'll have that imbalance maintained. And feel free to scale the number of apples on each side by some factor k, but in a way that makes physical sense for the model. K better be positive, and then that will still be imbalanced. Imbalance still maintained. So this real-world motivation has motivated a theory of inequalities. And I'm being kind to myself and not even going into the territory of negative scale factors here. In which case, okay, this model, this real-world motivation has developed for me a theory of inequality that I'm now going to play with in general. I'm going to say, here's my theory of inequality, that if I got one imbalanced statement, then these are logically equivalent to each other. Wait. All right, so where am I with this? This guy. How am I going to play with that statement if all I've got are these fundamental beliefs of inequality? Well, here goes. Negative 2x, I know, is imbalanced with negative 2y. I'm seeing negative numbers here as scale factors. That scares me. There's no mention of negatives here. So I'm going to see if I can just do some work to avoid negative numbers. And I think this is going to help me out because I can add whatever I like to the left and to the right and it will maintain the imbalance. So let me add 2y to the right and 2y to the left. And anything you like to left and right, the balance will be maintained. Now I've got that 2y minus 2x is less than 0. All right, still got some negative stuff going on here, but let's use this again. Let's add 2x to the left and 2x to the right. And I can now see I've got, 2y is less than 2x. Now I've kept my life in positive territory, great, just by using this rule a couple of times. But now I can see I can scale this by whatever positive number I like, and I choose scaling by the positive number 1/2. Half of that and half of that would still be the same in balance, but half of 2y is a single y, half of 2x is a single x, and I've maintained that imbalance. Imbalance, 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 maintained all the way through. I started here and have now ended up with this equivalent statement over yonder. That's it. I'm just using add, subtract, whatever you like, and scale by any positive numbers you like, and I've now got a statement. Since this particular problem had x stuff on the left and y stuff on the right, some people might say, no, you should present an answer that has x stuff on the left and y stuff on the right. Okay, now it's just a style thing. It's not math anymore. Okay, I could say instead that this is x is greater than y. And it looks like I've now flipped the inequality sign. I haven't really. I haven't at all. There's no flipping going on. It's just that I wanted a style thing and be writing things in a particular way. Okay. So this isn't actually a rule. There is actually no such thing as multiplying and dividing through by a negative number. It's just moving things around so you make life easier for yourself, so you can then multiply by, or divide by a positive number instead. And if you just follow your nose, life is so much easier. It's so much easier. But people complain, no, James, you spent 10 minutes doing that. If I just teach my kids a rule like this, we can be done in half a second. Well, if speed is the goal and not the thinking, great, go for it. Just have kids do that and they'll be fine. Unless they forget what's going on and get things muddled. Here's understanding. And so what if it takes an extra 10 seconds to work your way through it to make sure you really know what you're doing and you know why you're doing it? I say that's the point of teaching mathematics. So how do you know what you're doing and why you're doing it, and then be able to do it, actually do it, and convince others that what you're doing is correct and right and on track, on mark. So that's it. Why do you flip the inequality when you multiply or divide by negative numbers? You're not. You're actually maintaining it because there's no multiplication or division by negative numbers. What a crazy answer that one is.